Okay, so now we are still looking at the joint A, and we found the value from A to B, and this is in compression. It's 437.5 pounds. Now we need to find AD. So we have compression here happening, and we have something going on here at point D. So if we look at this, we're going to find these counteracting forces. So the sum of the forces is going to be minus AB in the x direction. Since this is negative 437, we are looking at the x component of AB. And we're going to assume that A to D is positive. We don't know, so we assume it's in tension, and we'll see at the end if it works out. And if we add those together, it should be equal to 0. So in this case, we're using the hypotenuse and the adjacent. Let's think about cosine for a moment. So cosine theta equals the adjacent over the hypotenuse. So to solve for the adjacent, we multiply the hypotenuse times cosine theta, and that gives us the adjacent. So that means the ABX is equal to AB times cosine theta. So we can go over here and say minus AB cosine theta is the same as ABX plus AD. And that should equal 0. Now we rearrange this to solve for AD. That is not a D. AD is equal to AB cosine theta. So when we move it over to the other side, we lose the negative, so that means it's 437.5 cosine of 53.13 equals 262.5 pounds. That is AD. So right here on your diagram, let's label that 262.5. We have found everything going on. Oh, and look, it's positive. It is in tension. Okay.